Hello everyone. In this video, I will discuss the law of sines and will provide you some examples of this law of sines. Suppose we have a triangle with angles A, B, and C. And we also have the sides side A, side B, and side C. Note that side A is opposite to angle A and side B is opposite to angle B and side C is opposite to angle C. The law of sine states that the side A divided by the sine of angle A is equal to side B over the sine of angle B. And this is also equal to side C over the sine of angle C. And this law of sines can be used to any kind of triangle, to right triangles or to oblique triangles. Let's take a look at some examples. Example 1. Given a diagram of this triangle, we have angle A and then we have this angle B which is 102 degrees and angle C which is 21 degrees. And we also have this side here, it's A, and this side is B, and this side 20 feet. Now we want to determine the measure of angle A and the length of sides A and B. First, we are going to solve the measurement of angle A. We know in Euclidean geometry or plane geometry, the sum of the interior angles of a triangle is always equal to 180 degrees. So the sum of angle A plus 102 degrees plus 21 degrees should be equal to 180 degrees. 102 plus 21, that gives us 123 degrees. So we have A plus 123 degrees is equal to 180 degrees. And subtracting 123 degrees on both sides, so we have A equals 57 degrees. Now that we have the measurement of angle A, we can now set up the law of sines to solve for this side A. So we have the law of sines. A over the sine of 57 degrees is equal to 20 over the sine of 21 degrees. And we cross multiply this sine of 57 degrees to the right side. So we have A equals 20 times sine of 57 degrees over sine of 21 degrees. A equals 46.8 feet. Now to solve for side B, we can set up another law of sines. B over the sine of 102 degrees is equal to 20 over the sine of 21 degrees. B equals 20 times sine of 102 degrees over sine of 21 degrees. B equals 54.6 feet. So our answers for this question is angle A is 57 degrees, side A is 46.8 feet, and side B is equal to 54.6 feet. Now let's take a look at example 2. A tree grows at an angle of 4 degrees from the vertical alignment due to prevailing winds. At a point 40 meters from the base of the tree, the angle of elevation to the top of the tree is 32 degrees. What is the height of the tree? So here's the figure. The tree is tilted to the side at an angle of 4 degrees. And then 40 meters from the base of the tree, this point here, the angle of elevation is 32 degrees. We want to find the height of this tree. Here is the triangle that represents the situation in this problem. So we have here 32 degrees on this angle, and the angle here is 94 degrees. This is 90 plus 4 degrees, so 94. And we are looking for the value of the height of the tree, or h. Now let's call this angle here B. Now we know that in Euclidean geometry or plane geometry, the sum of the interior angles in a triangle is always equal to 180 degrees. So angle B plus 94 degrees plus 32 degrees is equal to 180 degrees. 94 plus 32 is 126 degrees, and subtracting 126 degrees from both sides, we get B equals 54 degrees. Now that we have the value of angle B, we can set up the law of sines in order to solve for the height of the tree, which is h. So we have h divided by sine of 32 degrees is equal to 40 divided by sine of B. And cross multiplying this sine of 32 degrees, we have h equals 40 times sine of 32 degrees divided by sine of 54 degrees. We get h is equal to 26.2 meters. The height of the tree is 26.2 meters. Now let's consider our third and last example. A pole is tilted to its side at an angle of 8 degrees from the vertical position. A guy wire is used to support the pole, and it is connected to the ground 24 feet away from the bottom of the pole. The wire makes an angle of 40 degrees with the ground. How high is the pole and how long is the guy wire? So here's our figure. A pole is in blue. We want to find the height of this. And the guy wire in green, it's connected from the top of the pole to the ground. And the distance from the bottom of the pole to the spot where the guy wire is connected is 24 feet. The guy wire makes an angle of 40 degrees, and here the pole is tilted to its side with an angle of 8 degrees. So this angle here is 90 degrees plus 8, a total of 98 degrees. So let's redraw this diagram. So here's our diagram, the triangle, the height of the pole in blue, and then the length of the guy wire in green, we call this W. And then we have the angle here between the pole and the guy wire. It's angle B. And then on the ground, the angle of elevation between the guy wire and the ground is 40 degrees. This angle is 98 degrees. The distance from the bottom of the pole to the spot where the guy wire is connected on the ground is 24 feet. Now let's solve for the measurement of angle B. Using the sum of the interior angles in a triangle, we have B plus 98 plus 40 is equal to 180. And 98 plus 40 is 138. And subtracting 138 to both sides, and this gives us B equals 42 degrees. Now that we have the measurement of angle B equals 42 degrees, we can now set up the law of sines to solve for the height of the pole. So we have h over sine of 40 degrees is equal to 24 over sine of 42 degrees. And cross multiplying the sine of 40 degrees, we have h equals 24 times sine of 40 degrees divided by sine of 42 degrees. We have h equals 23.1 feet. This is the height of the pole. Now our next task is to determine the length of the guy wire W. Let's set up the law of sines to solve for the length of the wire. So we have here W over sine of 98 degrees is equal to 24 over sine of 42 degrees. And again, cross multiplying sine of 98 degrees, we have W equals 24 times sine of 98 degrees divided by sine of 42 degrees. W is equal to 35.5 feet. So therefore, the height of the pole 23.1 feet and the length of the guy wire is 35.5 feet. Okay, that's all for today. Until next time, thank you for watching.